Hello, I'm Edward Vincentas Mosquera, and today I'm going to tackle about Docker and containerization. So, Docker is an open source platform that enables developer to automate running their application. And also, containerization is that packages all the necessary dependencies, libraries, or configurations that is necessary to run consistently the application. So why I have a source online on what are the benefits or advantage of the Docker and why does people or developers uses it. So the source is from ChatGPT. So it says that Docker is useful because portability. So it ensures application to run consistently across various environments. So that is the first reason on why it is useful. And second is the speed, because containers start up much faster than virtual machine, making development and testing more efficient. And the last is resource efficiency. So containers are more lightweight compared to virtual machine, allowing multiple applications to run at the same time without significant performance overhead. So since, as what I've said earlier, that containers is the one who packages all the dependencies or libraries, so that is why we have three basta. So it says that portability and speed and resource efficiency. So the importance of containerization in software development. So first is consistency. So Docker helps improving in software development because it eliminates the work on my machine problem, ensures that applications work the same way in development, testing, and production. And second is scalability. So containerization make it easier to scale application horizontally by running multiple container instances. So all of this is, I will explain it much better once we have a Docker installed in my local machine. And isolation, each container runs independently, so preventing conflict between different application dependencies and improving security. And efficiency, container make efficient use of system resources, allowing developers to run more applications on the same hardware. And last is DevOps, or developer operation, and CI/CD, or continuous integration and continuous deployment. Container integrates seamlessly with CI/CD pipelines, enabling faster and more reliable deployment. So all of these benefits is I will explain it later once we are in the Docker or the Docker Hub or Docker installed in my system. So next, what we would do is installing Docker. So since I have a Linux machine, so I will install it I will install it in Linux. So I'm going to search docker download, and then this docker desktop, and get started. So since I have a Linux, I'm going to click this download for Linux, and also I have a Debian OS or Linux, Debian Linux. So this is the prerequisites that I must have to install a Docker. So first I'm going to copy this and open a terminal. Next is I'm going to copy this I know we must install this first. So installing methods, and before we install the Docker engine, need to set up first. So you're going to run this. Version and echo. Here we have so right now we have successfully installed the Docker. So to check if the Docker is really installed in your local machine, so we can check its version. So Docker version, so this is the command to check if the Docker is installed. As you can see, I have a version of 27.5.1. so next, what we're going to do is understanding the Docker basics. So the basic commands, so we have pull, run, images, and ps. So first we're going to do is we must pull. We must use the Docker pull. So we have a But first you need to go to Docker Hub or this link and search any images that you want to pull. So in my case, I want to pull this image, so just copy and then so the pull command in Docker is just like cloning a repository in GitHub, but in this case you pull images. But the concept of both concept is just like similar, but instead Docker is for images. So to check all the images, or to check if the Redis image is successfully pulled, so we can check it by Docker images. So as you can see, I have a two images. So this bash is what I pulled earlier, but for now we are going to test this Redis. So if we want to run this image or this Redis, so we can type run Redis. As you can see, it is now running. And then if we can check, so Docker ps, so this is the information of the image that we have run. So this is the container ID, and this is the image name, and command created, status, and ports and names. So if we want to stop the image, so we can just control C, and if we run this, so as you can see that there's no running as of now. And yeah, so I think that is all the basic Docker commands. So and describe the difference between Docker images and containers. So images is just like the where it is. So it is the images, like the repository. So repository is just like the resources that we must have, so in order to keep our application running. So and container is containers is the like the platform. So I have an explanation here. So container is the one who packages all the independence or dependencies and libraries to have our application consistency and efficiency. So next is we're going to tackle is running a Python script in Docker. So the first step is we will write a Python script that just print a basic information about my system. So we will create a documents Docker test, and then so here I have a just a basic script that will run once it is called. So if we will run the Python script here, so this just prints out the system information at the current home directory. So this is my home directory and this is my system information. So what we're going to do is we need to add a Docker file. So you can add a Docker file here, new file, and then inside in your Docker file, so it must have, no, it is not necessary, it depends on your situation, but in my case this is what I want. So the purpose of this, so every time this the Docker this will run the script, but the first thing that it will do that is this will run first. So it will run this update and it will install a Python, and then so our working directory is this, and then it will copy the py to our working directory. So I will explain this more later once we run this Python script. So in our terminal, so as you can see, if we check our images, so we have only one image, which is the Redis that we have used for executing the basic Docker commands. But for now, we are going to run this Python script. So in order to run, so you must go to this this path on where your script, and then once you're in the VS Code or the directory, so we should run a Docker run, and then name of Docker sudo Docker build. You must build it first, and then -t, and then the name of your image. So in my case, the name of this is system info, and then don't forget to add a because you're in a current directory where your code is stored. So if we click run, so as we can see this, it runs a update, runs and install Python 3, and then add a working directory which is user src, and then this script print.py is stored in our working directory. So if we check, as we can see that the system info is existed because I've built it using this command. So file, build our image, run the container, which is what we do, and show the output. So right now is we are going to run this image. So sudo docker run system info. Okay. So this is the output. So as you can see, this is root because we have set this into user src. So if we like want to check the working directory, so we can you just copy this command and system info and then bin bash. As you can see, we are in user the /src because this is what we have put on our working directory. And then, as what I've said earlier, that this script by print.py will be copied on the working directory. So since we are in a working directory, so you can check. So we are currently in the directory where the print.py is copied. So if we can ls this, so as you can see, print.py is existed. So it exists here because we copy it. And if we open the print.py, so this is the code. And then if we run the Python 3 print.py, and it will run. So and also if we check it here, the user that existed here is Ubuntu, not Subji, which is my username. So it's because this is what we have put. And if we change the directory, it has nothing, because the purpose of this is to copy only the script that we have on our working directory. So this is a directory that has its content. So if you want to exit this, just Control D to exit. So now we have demonstrated the script runs correctly inside the Docker, and then summarize what was covered in tutorial Ah, amping. Conclusion. So, the conclusion on summarize what was covered in this tutorial is that first, we know now how to install Docker. But first, let me recap on what is Docker. So Docker, as what I've said, is an open source platform that enables the developer to run their application consistently. And also containerization packages all the dependency, libraries, configuration that necessary to run the application. And also we now know how to install the Docker inside Linux. So this tutorial is for Linux users who wants to know how to use Docker. And also we know how to, or what is the purpose of the basic Docker commands, which is the Docker pull, Docker run, Docker images, Docker ps. So Docker pull is to pull a image that's in the Docker hub, and Docker run to run the Docker, or no, image to run the image, while the Docker image is to list out the images that your system currently has. And then the Docker ps is for us to check on which image is currently running. So, and also now we know how to create a script that integrates with Docker, and we know how to create a Docker file to containerize the script, just like this. What we have done is, so this automate all the process once we build this folder or script. And then we now build. So we did build the Docker image, so that the script that we have made will exist on our Docker image, and then run the container, and then show the output inside the container. So yeah, and also again, this is intended for Linux users or developers who has a Linux OS that wants to learn how to use Docker. And that's it. Thank you.